Okay, we've got video number 2. We've just finished video number 1. Took us hopefully not too long. Assignment. Bang. Okay. Open in Notability. Import. Open note. Too easy. Okay, let's see. Put our name in. Trent Rousseau. The date is the 5th of June 2024, and our block, I think that means like period, but it's after school, so I'll go like period 10. Okay, f of x equals 4. It's saying doesn't matter what you plug in for x, it'll always equal 4. So at this point it's going to equal 4. At this point it's going to equal 4. At this point it's going to, I think you get the idea. It's just a straight line. And that is going to be at y equals 4. Well, number of possible x-intercepts. It obviously never goes down to this line, so this is going to be a big fat 0. Value of the y-intercept. So that's when it crosses through this line, which is at the point, you guessed it, y equals 4. The range, well, if we go all the way to negative infinity, and we cross all the way to infinity, the lowest we'll ever go is going to be y equals 4, which is around about here, and the highest we'll ever go is y equals 4, which is around about there. So our range is y equals 4 to y equals 4, which is just y equals 4. Number of possible turning points. How many times does the line get squashed in either direction like this? Well, it's a straight line, so 0. Also, it says possible turning points. So actually that's just the highest degree, which hopefully you watched the other video first. If you didn't, I explained degree in the chapter 6 practice test video. But the degree, the highest degree of this is 0, because it's x to the power of 0 is 1. So this is 0. And end behavior, it's saying the behavior at the ends of each graphs. I think. Wait, let me just look at the answers. Oh, it's just saying what quadrant it goes into. Yeah, so basically what I was saying. We didn't actually get taught using quadrants, but it's going from, this is quadrant 1, this is quadrant 2, 3, 4. It's like counts anti-clockwise, and it's obviously going from 2 to 1, right? Reading from left to right, like all English people do. Sweet, now we move on. Next one, negative 2x plus 6. So, main things to look for here. Negative gradient, which means it is going to be sloping from top left to bottom right. And then plus 6 means it will be intercepting at y equals 6. So we'll adjust our dots slightly to go like here and here. And the x-intercept, you let 0 equal negative 2x plus 6, and 2x equals 6, x equals 3. We're letting it equal 0 because it's at the point y equals 0. That's this line, and that's our x-axis. So when it crosses through this line, it's going to be at our x-intercept. X equals 3. So draw this straight through. Bang, too easy. And this point here is going to be at 3. That was not a very good 3. There we go, 3. Arrays are working out. Number of possible x-intercepts. As we can see, it's just 1, because it only crosses through once. And this isn't turning down at any point later on. Should really use a different color. It's not turning down, we can see it's a straight line. So it's never to come back through this line at any other point. Value of the y-intercept, we have it labeled right here, nice and clear, it's 6. And the reason we know that is when x equals 0, this whole term is going to cancel, because negative 2 times 0 is 0. and 6 is not multiplied by x, so it stays as 6. So this is going to be 6. Our range, it goes from the very, very bottom, the depths of hell, down here, to up high in the heavens, up here. And that means that it has a range from negative infinity to infinity, which is just y is all real. Possible turning points. Again, it's a straight line. It doesn't squash in either direction. And our degree is 1. But your possible turning points is like 1 less than whatever the degree is. So this is still just 0. Except this is never going to be negative 1. And behavior, we've just been over it. It goes from quadrant 3 to quadrant... from quadrant 3 to... Oh my goodness. 1, 2, 3, 4. From quadrant 2 to quadrant 4. Perfect. Q, 2, Q, 4. Negative x squared plus 9. Again, negative. Bang. Negative gradient. But it is a degree of 2, which means if it is usually a happy face, which is x squared, it is now turning into a sad face, which is negative x squared. And the way that you think about it is if you put a really, really small number in there, like let's say negative 100. Negative 100 squared is going to be negative, and then the negative here gets cancelled because it's squared. 100, 10,000. That is a really small negative number, so it's going to be bang, all the way down here. If you put a really big number in here, like 100, you're going to get negative 100 squared, which is negative, what do you know, 10,000. So you're going to come all the way back down here again. And then if you put a small number in here, like 1, it just becomes negative 1, which is up here, right? So that's how you can sort of envision the shape. If you ever get confused, just sub some numbers in. Or use Desmos, which I don't know if you're still allowed to use. If you are, I don't know why I'm teaching all of this. You could just plug it into Desmos. And then plus 9 means if you let x equal 0, like I just talked about, it'll intercept at 9 up here. So take this beautiful shape and move it up here. That's obstructed our lovely 9, so we'll put a 9 there. Bang, too easy. Number of possible x-intercepts. We will use our eyes. That is 2. If you can't use your eyes for whatever reason, it's just going to be the degree. It's always going to be 2. It's not necessarily always going to have 2, but here it says possible x-intercepts. An example of when it wouldn't have 2 is if it was like just negative x squared. Then it would look like this, and it would only touch 0, so it would only have 1. But that's besides the point. Value of y-intercept. Y-intercept is up here at 9. It's always going to be the constant, the one that doesn't have x on it. Range, it goes from 9 as the highest, all the way down to negative infinity as the lowest. And so our answer is going to be y is less than or equals to 9, because it can be 9, but it can't ever be bigger than 9. Number of possible turning points. How many times does the line get squashed in any given direction? It gets squashed once, right? It's going up, and then it's coming down. Bang, squashed once. The way to actually teach that is like different, but there's no need to do that. It changes direction once, so boom. It's also the degree minus 1, which is what I just mentioned before. 2 minus 1 is 1. And behavior, it goes from quadrant 3 to quadrant 4. Remember 1, 2, 3, 4. So Q3 to Q4, and all done. And then for our last one, 2x cubed plus x. We know that if we subbed in x equals 0, it would be 0, right? Because there's no constant added. And if we sub in y equals 0, it's also 0. because like 0 equals 2x cubed plus x. Divide both sides by x. Ignore that train of thought. Let's just plug it into Desmos. That was embarrassing. Ignore that. Yeah. So if the x-intercept is 0, the y-intercept has to be 0. That's a way better way of looking at it, because like when x is 0, y is 0. You know, that point encompasses both of that. And then it's a positive cubic, so it's going from down here up there. Boom, number of possible x-intercepts. Possible x-intercepts is always going to be the degree, like I said earlier. So this is actually 3, but for this function we can see that there's only 1. So if it says number of x-intercepts and not the possible here, it would just be 1, but it says possible, so it has to be 3. Value of the y-intercept, 0. We just got over that in a very embarrassing manner. The range, it goes from all the way down here to all the way up there. So y is an element of all real. Number of possible turning points is 2, because it squashes in. Even though it's subtle, it squashes in there and there. I could exaggerate it by drawing it like that, but it's not really that gradient, that's correct. But yeah, like it squashes in once and once. So 2. And again, it's the degree minus 1. 3 minus 1 is 2. And then, actually, yeah, okay. End behavior goes from 3 to 1. And Q3, Q1. Also, I just want to address something I've just realized I've been explaining really badly. This actually isn't really a turning point. It's a point of inflection. So a turning point is when it actually goes downwards. But here, it goes like that. See how like on this point, it goes flat and then it keeps on going upwards. It never goes downwards. So it's actually 0. But this answer is still correct. There's 2 possible ones. The degree minus 1 is going to be the maximum possible ones. And wow, there's a lot left to go. I'll have to finish this video another time. I'll do this one quickly and then I'll go, because I've got a function to get to and not a mathematical one. Negative 2x squared minus 2x. We're just expanding here to figure out the degree. You don't really have to expand, but this is like the brute force way of doing it. Negative 2x to the 4 minus 2x to the 3 minus, plus 6x squared. Plus 6x is the full expansion, and the highest power is 4. Another way of doing it is you just count the number of x's. So that's x squared times x is x cubed times x is x to the 4, because you know that like all of these terms will end up having to multiply by each other. So the degree equals 4. The y-intercept is a little bit different. In this case, it's 0, because there's no constant function on the end. But the y-intercept is going to be for when you let x equals 0, right? So let's just demonstrate that. Negative 2 times 0 to the 4 minus 2 times 0 plus 6 times 0 to the squared plus 6 times 0 equals 0. Because all of these just 0 out. So y int equals 0. Okay, I'm sorry to love you and leave you, Nixon, but I'll finish more videos It'll be a lot more helpful if you send me the stuff you're really struggling with, like detail it, because it works out really poorly time zone wise for me to do every question in every chapter. But if I just do like, you know, the ones you really need help with, then that'll be a bit easier. And the bell is literally going, so yeah, there's a football match that we all have to watch, rugby match, rugby league, so I'll talk to you. Well, not talk to you, I'll make another video for you another time. See you next time.